Hello everyone, welcome back to our channel, and today we are going to learn about factorization. This is a clear progression from the linear algebra identities we have worked on previously. So let's get started. So in the previous classes, you have definitely learned about some composite numbers that can be expressed as a product of prime numbers. So let me give an example of say 42. It can be written as a composite of 2 into 3 and 7. So all these are prime numbers and these are prime factors of 42. So what this does say is that there's a similar way in algebraic identities where algebraic functions where we can write each expression. There's a similar way in algebraic expression where we can write the factors uh, of such expressions. So let's get started. So let's take an example of 3a square plus into 5a plus 4b. In this, we can, in the brackets, to get 15a cubed plus 12a square plus b, 12a square b. And here we can say that 3a square and can say that 3a square and 5a plus 4b are factors of 15a cubed plus 12ab. So that's the fact that those are the factors of this bigger algebraic expression. So thus we come to the definition of factorization, which states process of finding two or more expressions whose product is the given expression is called factorization. And now we will look at it through the lens of an example. So product and factors go hand in hand. So let me create a table. So if we say we have 7xy, 5xy, when we create a product of these, we get 35x square y square minus 21xy. And when we go back again, so this 35x square y square minus 21x can again be written as 7xy to 5xy minus 3, which are the factors. So that's how the product and factors go hand in hand. So we'll start with the first topic where we take factorization by taking out the common factor. So in this we first find the HCF, sorry, cut. So in this we first take the HCF of all the terms in the given polynomial, and then we divide each of the term in the given polynomial by the HCF, and then enclose the quotient within the brackets and keep the common factor outside the bracket. I'll show that through an example. So let's start with simple one. So we have 24x cubed minus 32x squared. So how do we factorize this? We first take the highest common factor for 32x squared and 24x cubed, and that comes out to be 8x squared. We can calculate this by taking out the common HCF. I'll do that very quickly over here. 24, 32, take HCF out. So we have 24 here, 32, that comes out to 3. Cool. So 8 is our highest common factor, and out of x and x cubed, x square and x cubed, we have x square as the lowest fraction. So therefore, we have 8 from the numeric side and x square from the variable side. And then we'll take out what is the quotient left. So if we divide 24x cubed by 8x square, we get 3x. And if we divide 32x square by 8x square, we get 4 minus 4. So that's how we calculate the factorization by taking out the common factor. Let's try another example. So here we have a bit of a complicated equation where we have 3x into y plus 2z, and then we have to add it to 5a y plus 2z. So in this type of an equation, in this type of an expression, we need to first solve the expression. So we have 3xy plus 6xz plus 5ay plus 10az. So let's take our next example of 3x into y plus z plus 5a y plus 2z. So in this we can see the HCF of this value and this value, value 1 and value 2 is y plus 2z. So we'll take out the HCF out of these, and that comes out to be y plus 2z, and then the remainder, sorry, the quotient would be in the other bracket, that is 3x plus 5a. So that's how we factorize this. Next, we'll look at factorization by grouping of terms. So basically, when we are doing this for a given polynomial, we first arrange the terms in the polynomial in groups such that each group has some common factor. And then we factorize each group on its own. And then we take out the factor that is common in each group. So let me try that using an example. So let's take the example of 4x squared minus 10xy minus 6xz plus 15yz. We have this expression. So what we'll do in this one is first we'll find any common factors in every particular thing. So we can try this according to the way it is already written. So we can take these 4x squared minus 10xz, like xy, and we can take minus 6xz plus 15yz. So in this 4x square and 10xy, we have to take out the common factor, and the common factor here is 2x. So, and then we'll take out the quotient, and the quotient, when we divide 4x squared by 2x, we get 2x again. And then we multiply 10xy by 2x, we get 5y. That's our common factor. And then we have, for the highest common factor for 6 and 15 is 3. We'll take 3 out. And for xz and yz, we have z. This is 3z into, when we divide minus 6xz by 3z, we get minus 2x, and we get plus, when we divide 15yz by 3z, we get plus 5y. So because these two terms have opposite opposite values of the sign, we can change that pretty quickly. So let's have 2x minus 5y. This remains the same. If we take out the minus from inside and keep 3z the same, we'll have 2x minus 5y. Now we can take out 2x minus 5y from both these parts, and then we can write the quotient of 2x minus 3z. And that's how we solve this by grouping terms. Let's try another example. So we have x cubed plus 2x squared plus x plus 2. How do we solve this? So we'll follow the similar trajectory that we did in the previous question. So we'll make the groupings of x cubed plus 2x squared and x plus 2. So the common factor between x cubed and 2x squared is x squared. So x cubed minus x squared gives us x, and 2x squared divided by x squared gives us, we have x plus 2. And here we will take 1 as a common factor, as there is no common factor, so 1 only remains there. So we'll have x plus 2 over here. Now we can take out the common factor, x plus 2, from both two expressions and write the quotient here as x squared plus 1. So that's our factorized version for this question. Next, let's try another. We have 8x plus by plus bx. So we have this expression. So let's group all the a terms and then all the b terms. So we have ax plus az plus ay. We have by plus bx plus bz. We'll take a common in the first three terms. Also provide brackets so it makes more sense. We'll have x plus z plus y. And in the second one, we take out b as the common factor. We have y is x plus z. See, these two terms are the same, just the x, y, z have different orders. So we can take that as common. So x plus y plus z. And then we'll take the quotient in the other bracket, and that is a plus b. And that's our factorized version for this. Let's try another one where we have factorization using algebraic identities. So when using this, we can use some identities like a plus b whole square, which gives us a square plus 2ab plus b square. We can use another identity a minus b whole square, which gives us a square minus 2ab plus b square. So these are the two identities that we can use for questions relating to algebraic identity factorization. So let's try some questions. So we have this question where we have 9y square minus 30y plus 24. So we know we can see that this is a version of a square minus 2ab plus b square. So we'll try to put this identity here. Just write that down. So we'll try to make this expression similar to what it looks like this. So let me show you how that's done. So 9y square can be written as 3y whole square. We'll come back to 30y, but before that, let me let's look at 25. So 25 can be written as 5 square. So now we have a, which is equal to 3y, and then we have b, which is equal to 5. Now we have to write 2ab, and 2ab will come out to be 2 into 3y into 5. So let's write that down. Minus 2 into 3y into 5. And if we calculate this, this comes out to be 2 into 3 is 6, into 5 is 30. That comes out to be 30y, and that is what we are looking for. So we have done that successfully. So now let's write that down. 3y minus 5 whole square, or we can also write 3y minus 5 into 3y minus 5. So that's that. We'll try another example where we have to use the positive one. So we have x squared plus 14x plus 49. We'll again use a square plus 2ab plus b square. So let's start. Our x square can be written as square of x. We'll write 14x later, and 49 can be written as 7 square. So now we know the value of a is x, b is 7, and 2ab can be written as 2 into x into 7, and that is equal to 14x. So we're on the right track. So 2 into x into 7, and then we can write this as x plus 7 whole square, or x plus 7 into x plus 7. So that's how we factorize this kind of a question.